So you can prove figures are similar using a transformation. If two shapes are similar, or two figures are similar, then there's just a dilation between them. Maybe a reflection and a rotation also, but ending with a dilation. So if they're similar, you can use reflections, translations, rotations, and dilations. Back when we talked about congruent, we were not allowed to use dilations, which is why we didn't learn it. And then two figures are similar if we can do those transformations and show that they're the same. So you can perform a dilation using coordinate notation, just like we did for reflections, rotations, all that sort of stuff. Now, the only difference is you're going to use the scale factor k, and that's what you multiply by. So if you are going with a scale factor of 2, you would just multiply the x and the y coordinates by 2 if it's centered around the origin. The center of dilation is the origin. That's kind of important here. So you can just multiply by whatever the scale factor is to the coordinates, and that would be the new coordinates after the dilation. So if we are to determine if two figures are similar using transformations, we're just going to check the pre-image with the image. So it says RST, that is the pre-image. 0, 1, negative 1, negative 1, and 1, negative 1. There's the coordinates. And in the image, 0, 3, 3, negative 3, and negative 3, negative 3. So if this is a dilation, a transformation, there's a k value that we can multiply the coordinates by and get those new numbers. So to get 0, 1 to become 0, 3, we can multiply by 3. 0 times 3 is 0, 1 times 3 is 3. To get 1 to become 3 and negative 1 to become negative 3, you multiply by 3. And then same thing for t. Since they all have that same k, that same scale factor, it is a dilation with scale factor 3. So yes, they are similar because it's a dilation with scale factor of 3. You do the same thing here. T is at 2, 2. W, which matches with that, is at 5, 5. Q is 2, 4. X is 5, 9. R is 6, 4. Y is 12, 9. And then Z is 12, 5. S was 6, 2. So if these figures are similar, that means there's a scale factor, k, that you can make 2, 2 become 5, 5. It's a little bit hard to think of, but it would be 5 over 2 would be the scale factor. That works for both of them. It also works here for the 2 to the 5. Yes, that works. But 9 over 4, that's different. That is not 5 over 2. So it does not work for that scale factor. And then you see that again here. From 6 to 12, you'd multiply by 2, but from 4 to get to 9, you don't multiply by 2. So the scale factors are all different all over the place, so no, they're not similar. Different scale factors throughout. So for this, we can look at the coordinates 1, 2 to get to 2, 4. From L to G, that would have to be multiplied by 2 and multiplied by 2. That works. Scale factors 2. But it needs to be the exact same for all the other coordinates. So from 1, 6 to 2, 12, multiply by 2, yes. Multiply by 2, yes. 4, 6 to 8, 12, multiply by 2, multiply by 2, yes. And then 4, 2 goes to 8, 4 times 2, yes. Scale factor is 2, so it's a dilation. The similarity transformation is a dilation with a scale factor 2. Spell it correctly. And it's centered at the origin. So for this problem, it is a little bit more difficult to figure out because it's going to be a combination. It's a series of a dilation with probably a translation or something else in there. So you could really do it in whichever order you want. So if you start with the dilation, you can see that the side here has got a length of 4, and then down here it's only got a length of 2. So to get from ABCD to EFGH, or EFHG actually, we have to get it smaller. So we have to have a scale factor which takes a 4 down to a 2. So the scale factor, K, has to go from 4 to take a 4 and make it become a 2. So the image is a 2. The pre-image was a 4. That's 1/2. The scale factor is 1/2. So if we did that, centered at the origin, that would take this point here, which was 2, 2, negative 2, 2, times 1/2. So negative 2, 2 would go to multiplied by 1/2, you get negative 1, 1. So that would be C. Do the same thing with A. If it's at 1, 6, multiplied by 1/2, you get 1/2, 3. That would be A prime. Do the same thing with B. That's over here at 5, 6. Multiplied by 1/2, you get 5 over 2, which is 2.5. And then 6 times 1/2 is 3. You can do the same thing with your D coordinates, which are 2, 2, times 1/2, you get 1, 1. So if we start with a dilation with a scale factor of 1/2, it says use coordinate notation. That means x, y goes to 1/2 x, 1/2 y. Then we have to translate it or slide it over to where it's supposed to be. So C is supposed to go over here down to G. So it has to go to the right 2 and down 1, 2, 3. Right 2, down 3. Do the same thing with D. It matches up. B prime matches up, and A prime matches up. So it's first a dilation with scale factor 1/2, and then a translation by the vector 2, negative 3. If you write that in coordinate notation, that'll be x plus 2, and y minus 3. So for this one, I think a good start would be 90 degrees counterclockwise rotation. That would take JKL and rotate it 90 degrees around. So instead of being 0, 1, the rule for 90 degrees counterclockwise is negative y comma x. So 0, 1 would actually go to negative 1, 0. K, which is at 1, 2, we go to negative 2 comma 1. And then L, which is at 3, 1, we go to negative 1 comma 3. Now it looks like it still just needs to be reflected. So if we reflect over the y-axis, now we reflect over y-axis. That rule is xy goes to negative xy. So J moves there, K here, and L there. So now we have it in the correct orientation. It looks like now if we just multiply by 3, so use a scale factor of 3 for the dilation. Think it'll work out. So that goes to 3x, 3y. So if you multiply by 3, 0 or 1, 0 goes to 3, 0. That matches up. 2, 1, that will go to 6. 1 times 3 is 3. That matches up. And then the last point, L, 1 multiplied by 3, you get 3. And then the height was 3 multiplied by 3, you get 9. And that matches up. So it's a 90-degree counterclockwise rotation, then a reflection over the y-axis, and a dilation with scale factor 3. So this time we're taking PQRS, so the one over here in quadrant 1, and making it match up with TUVW. So it's definitely going to need a dilation with a scale factor smaller than 1, a fraction, because this side length goes from 3 to 1. So you take the image over the pre-image, that's going to be our scale factor. But you can do the length of the image over the length of the pre-image to get the scale factor. But we can either do that first or last, it doesn't matter. Let's do it first. So that would be xy goes to 1/3 x, 1/3 y. Just divide each coordinate by 3. So 3, 3 divided by 3 is 1, 1. 6, 3 divided by 3 would be 2, 1. R is out here at 9, 6. Divided by 3, you get 3, 2. And then Q is 3, 6. Divided by 3, you get 1, 2. So it looks like we're right on track. We just have to reflect it over the y-axis to make everything flip over. So the rule for y-axis is negative xy. and then Q would match up, P would match up, S would match up, and R would match up. So there's another one. We're going to take ABC, this one down here, and make it match up with DEF. So it needs to be, looking at it, we can see it needs to be rotated around about 180. We could start with that if we want. So the rule for that is XY goes to negative X, negative Y. So here's our point, -2, -1. Turns to +2, +1. B over here is at -6, -1. That'll turn to +6, +1. And then C is 0, -5. That'll turn to 0, +5. So you could translate first or dilate next, it doesn't matter. If you want to do your dilation, you'd see how far AB is. That's 1, 2, 3, 4, and it's supposed to have a length of 6. This has a length of 6. So that means the dilation, which is the image over the pre-image, would be 6 over 4. You can reduce that to 3 over 2. That's your K, your scale factor. So if you then dilate by 3/2, we get new coordinates of multiply by 3 and divide by 2. So we're currently at 2, 1. Multiply by 3, you get 6, 3, and then divide by 2. So that means that our coordinates there for A goes from 2, 1, and we're multiplying by 3 over 2. So that would go to 6 over 2, comma, and multiply by 3 over 2, so that's 3 over 2. So A is going to move to 3, comma, 1.5. 3, 1.5. B, which is currently at 6, 1, multiply by 3, divide by 2, that's 18 over 2, multiply by 3, divide by 2, you get 3 over 2. That goes to 9, 1.5. And then C, which is currently up here at 0, 5, multiply by 3 and divide by 2, you still have 0. Multiply by 3, 15 Divide by 2, you get 15 over 2. That's 7.5. 0, 7.5. So we're taking these 3 red points, and we have to now match them up with where they need to go. So A has to now go 3 to the left and up 1.5. 3 to the left, up 1.5, or you could say 3 halves. Do the same thing with C. 3 to the left, yep, up 1.5, yep. 3 to the left, 1.5, yes. So then your last step is that translation. So you do the same thing with this shape. You'd have to rotate it around so that Y matches up with L. No, that's not right. Y is going to match up with M, Z with N, V with J. You can look at the letters the way that they're written out to help you. So JN has to match with VZ. So this length currently has a length of 4. VZ has a length of 2. So to get to a 2, when we're starting with a 4, we have to multiply by our scale factor of 1/2. Thing you want to end with is a 2, that goes on top. What you start with is a 4, that goes on bottom. So that's our scale factor. So we don't have to do around the origin, especially since there's no origin drawn in. We could do everything around point J if we wanted to. So that way J would stay put, but then N is going to shrink in, M will shrink in. So let's do it all around that. So if we're going 1/2 the way from N to J, so N prime matches up halfway there. K prime is going to do the exact same thing. So if we're K prime is going to be halfway from J to N, currently we have to go up 4 and left 2. Do half of that. Up 2 and left 1. That's where K prime will end. L is currently 6 units straight up. Half of that would be 3 units straight up. And then M, currently 1, 2, 3, 8 units to the right and up 4. We have to cut that in half. 4 units to the right and up 2. So you could pick any of these points you want to be your center of dilation. So you dilate K is 1/2 and J is the center. That's what we just did. In translation. So then we need J to match up with V, because J is first, V is first. J needs to match up with V. So for that to happen, you translate seven units to the right. You don't have to go up or down, just 7 units to the right. So that puts J there, N there, M is right there, there's L, and there's K. So to get everything then to match up, it just needs to reflect down across this line. That line that goes through VZ. or you could call it JN if you want. And then everything would match up. The very last thing here in the notes, it's just that all circles are similar. It's kind of, there's a proof we could go through, we're not going to, but all circles are similar because they are just dilations. So you either have a bigger radius or a smaller radius, they're all the same, they're all similar.